Section 6.1, composite functions. In this section, we are going to be talking about the composition of functions. I'm fairly certain that this is probably something that you have seen before at some point in your math life. So hopefully this will be just a review for you. So let's go ahead and talk about what the composition of functions is. Back in, let's see, what section was it? It was probably 3.1. We learned to combine two functions. So if you were given an f and a g, we combine those functions through addition, subtraction, multiplication, and division to get a brand new function. And then once we had our new function, we found the domain of it. You could plug something into it. Composition is another way of taking two functions and putting them together to get a brand new function, okay? So it is denoted by this little circle, okay? Do not confuse that circle with multiplication. So if it were a multiplication problem, the f and g would just be side by side with either nothing in between them, or you would have a simple dot. But this open circle in the center means composition. So when you see this, it's equivalent to this notation, okay? This is pronounced f of g of x, okay? This is also pronounced the same way. This would be composing them in the opposite direction. So this would be g of f of x, okay, down here. Okay, so just remember, if you see that open circle in between two functions like this, it is denoting composition. Okay, all right, so let's just read through this. Okay, so the first statement up here, it says, given two functions f and g, the composite function f of g, and again, I remind you right here, it is pronounced f composed with g, or you can say it as f of g, is defined by this statement. So if you see the little circle, okay, this is the function name of x. It is equivalent to this, f of g of x. You can write it this way. This is probably the best way to work with composition, is thinking of it in this notation, okay? So if you are given this format, immediately write this and start working with it this way, okay? When we talked about adding, subtracting, multiplying, and dividing functions, we talked about order, and we said order did not matter for addition or multiplication, but it did matter for subtraction and division. Order really matters also for composite functions. F of g is not necessarily going to be the same thing as g of f. Sometimes they are the same, but don't bet on them being the same, okay? So in the next statement, the composite function g of f, or g composed with f, is notated this way. So if you see this, you want to immediately write down this, okay? So you eliminate the circle, okay? Because it's easier to work with that, okay? So what is composition, okay? Next bullet here. It says, think of compositions in this way, okay? Just as we substitute a number into a function, we may substitute a function into a function, okay? So basically what is going on is we are used to plugging in a number, okay? So like, I don't know, here, I'll make something up. If I gave you, we're used to having like one function, so maybe f of x is equal to negative 2x plus 5, and then if I ask you to find f of 0, you're plugging a number into the function. Everywhere you see x, you're going to replace it with 0, and you're going to get the output of 5. That's what we're used to, okay? What you're doing in composition is you're actually plugging an entire function into another function to get a new function, okay? So you're plugging a function into a function, okay? So I'll even write that right here. So all composition means is that you are plugging a function into a function instead of plugging in just a number, okay? Again, cannot emphasize this enough. In general, f of g is not the same thing as g of f, Okay, again, it can happen. You could compose them in both directions and get the same thing, but it's not always the case. Usually you won't get the same thing. Okay, so you need to pay attention to the order. Are you finding f of g or are you finding g of f? Okay, all right, last thing here on this page. Oh, hold on, this bullet. Okay. Domain. Okay, so like I said, you're going to take your two functions, f of g, and then you're going to form the composite function, okay? Either f of g, or you may find the other composition, g of f. The domain, it's going to be a brand new function, whatever you form, and so you might be asked to find its domain, okay? So if you read this statement here, it says the domain of f of g is the set of all numbers x in the domain of g, such that g of x is in the domain of f. And in the same way, the domain of g of f is the set of all numbers x in the domain of f, such that f of x is in the domain of g, okay? When I read that, I mean me, I've been doing this for years. I read that statement, it's out of your book. I am like, what are you talking about, okay? I don't want you to worry too terribly much about what this statement is saying. What I need you to get out of this statement is that the domain of a composite function is tricky, okay? It is not as straightforward as it might seem, okay? We're going to do plenty of examples of forming composition or forming composite functions, and we will find their domains. So you can see what I mean by their domains being a little tricky, okay? Don't worry about, you know, the specifics in this statement, okay? It is going to be a little tricky finding the domain of composite functions, but we will do enough examples that you will hopefully understand, okay? All right, last thing on this page is a function machine. It is an illustration of composition, specifically the direction f of g of x, okay? So the way this works is, okay, we're dealing with functions here. So you've got f and you've got g. They're two separate functions, okay? You are going to plug something in and you're going to get something out, okay? When you form that composition, you are going to get a brand new function, okay? So you're going to be able to plug something into it and get something out, okay? So the way composition works is, again, this is f of g of x, okay? What you should notice with composition, there is always an inside function. So in this case, g of x is our inside function. It's inside the parentheses, okay? And then f of x, or f, is our outside function. Actually, let me go back and write it this way because I don't want to confuse you with the of x notation. Okay, so we're going to say g is our inside function because it's inside, it's on the inside, okay? And f is on the outside, so it's our outside function, okay? So the way this works is you start with some input. We know inputs are x values, okay? So you're going to start, you know, follow the order of operations. You're going to start inside the parentheses here, okay? You're going to first plug that input x into the inside function, so the function g, okay? That's going to give you g of x, okay? So you're going to plug in x to the g function. That's going to spit out the output g of x, okay? And then whatever that number is, then it is plugged into the outside function, f, okay? And then f will apply its rule and spit out some final number, which is f of g of x, okay? So basically your input goes through the inside function first, okay? And then that rule does something to the input and spits out a number. And then that number is the input to your outside function. And then the outside function applies its rule and spits out a final number.